we're going to be doing some examples now over all the different classifications and looked at so far with the vocabulary with triangles. The first thing says to classify the triangles. So when you see that word classify, we know how to classify these triangles by the number of, or by the angles, types of angles that they have, and also by the sides that they have. So looking at that first triangle in this example, what do you notice about it?
Well, I see that triangle has only stuff labeled about the sides. I don't see anything about the angles. So that means I can only classify about the sides, technically, right?
Right, and we're not going to make any assumptions about the angles. There's things that we will learn later that may help us learn or talk about more things, but for right now, we are only going to go with what they give us.
Okay, so I see that all sides are labeled congruent, which means that's an equilateral triangle. So, again, the fact that I don't have any angles labeled, I can't say anything about the angles. It looks like it's an acute triangle, but I can't really say anything about it.
Perfect. All right, let's take a look at this next triangle, triangle NUR. What do you notice about that triangle?
Well, I see an angle labeled, and it's a right angle, so that means that's a right triangle. And I also see two of the sides are 16, which means it's isosceles. Awesome. And since the two sides are congruent, they don't have to be 16. They could be two different values, but they're congruent. So it's isosceles and right, or right and isosceles.
Exactly. And the order that you say those won't matter. You could say right isosceles or isosceles right triangle. Notice that I put the congruent marks on there. Since you had made the comment about congruent, Mrs. Palermo, I went ahead and added that on there. But if you realize that they are the same measures, we know that that's the definition of congruent, is that they are the same measures. So having those is great. Adding the tick marks is awesome too. Mm-hmm. Okay. What about triangle ABC?
Okay. Well, this is the first one I don't see anything labeled about the sides. So we can't make any assumption. They kind of look like they're all the same length, but we can't really assume that yet. So I'm just going to state stuff about the angles. And I notice all the angles are 60 degrees. So acute would work, but the fact that they're all the same, that means they're all congruent, which means equiangular. Now, if I put acute as well,
you really just don't need acute, because you want to use the most specific name.
But if I just said acute and not equiangular,
then that's not quite correct, because there's something more specific about it.
Good deal.
Good question. All right, let's take a look at CSW, triangle CSW.
All right, well, that one is just a right triangle. Mm-hmm. For sure, and I don't have anything labeled about the sides, and I don't want to assume it. It kind of looks isosceles, but I don't know for sure.
Exactly. So when you're naming these, use the most specific name that we can with the information that we're actually given. So notice that, like she said, triangle ABC looks acute, or looks equilateral maybe, but we don't know that. They don't give us that. Only go with what they actually give
and
you.
When you're classifying, that's what you're looking for, all of these types of things. So this next question says we're going to find some angle measures. Now, if you look at this particular picture, we have some measurements that are provided. You see the angle 1 and angle 2. What else are you noticing?
Well, I noticed that they give us an exterior angle. They give us that piece off to the side. One of the sides kind of just extends beyond the triangle. It keeps going.
Which basically means what?
It means that we have an exterior angle. It means that that exterior angle measure should be equal to the sum of the other two interior angles.
So thinking about that exterior angle theorem, so the exterior angle equals the sum of your other two. So remember what we use, that non-adjacent interior angles? Man, it froze on me and then I can't get it. So non-adjacent angles. All right, so
if I have to, me about it. Okay, if I have to find both angles 1 and 2, I'm going to go ahead and, using that exterior angle theorem idea, let's find angle 1 first.
Okay.
So the measure of angle 1 plus the 57, the other interior angle, together should be the same as that 82, that exterior angle. Because that's what we learned.
Exactly right.
That exterior angle theorem.
So if I subtract 57 from 82, you're getting 25.
So that angle 1 is 25. Now, knowing that, I really see two different ways that I could get that angle 2. I could talk about the linear pair that exists there, because I know that an exterior angle and its corresponding interior angle are always a linear pair. So I could just take 180 minus the 82, but I also realized that I could use the triangle sum theorem.
Okay.
So there's really a couple ways that I could do that to find that measure of angle 2.
Now, you talked about the triangle sum theorem. Now, the thing about that, and this is something just to kind of think about, is that involves finding that angle 1 first. So what if you made a mistake with angle 1? Well, then your angle 2 is going to be wrong.
Yeah.
So if we do the linear pair idea, which I love that you suggested that, I do 180 minus the 82, and you're getting, what, 98? So doing it where it doesn't depend on something we found, we could then check our work, right?
Oh, love that.
So we could check to see, does 98 plus 25 plus 57, does that really equal 180? And it does.
And it does, okay. So that's a good check more than anything else. I probably want to go ahead and not rely on information that I found if I don't have to.
Yeah. But like Mrs. Hookery was saying, there's options. You could have found angle 2 first and gotten 98 degrees, and then use triangle sum theorem to find angle 1. So there's a variety of ways. It's just a matter of if you want to use the information. It's not always the best option just because if you make a mistake, but most of us can handle a problem like this.
Yeah, I think so. Okay. This next problem that we have up here kind of requires the use of that exterior angle theorem. And if you take a look at what we've got here, notice that in the picture, what do you see?
Okay, well, I look at the picture and I see an exterior angle. I see the two angles that are non-adjacent, the two interior angles that are non-adjacent labeled. And I don't see the other interior angle labeled, and they don't give you information about it. So we can't really use that to find anything. And what we're going to do is find the value of x first, and then we're going to find the measure of the exterior angle. So makes sense that we'd have to find x because I look at that exterior angle and x is involved in it. So let's see. What can I do? Well, I know from the last slide, exterior angle is equal to the sum of the two non-adjacent interiors. So I know 2x plus, or minus 11, sorry, is equal to x plus 72.
Perfect. So that exterior angle is the sum of the two non-adjacent interiors. And now it's just a basic equation to solve.
So then x would equal 83.
All right. Now I'm going to go ahead and put an 83 up here. And what would this angle then be?
Well, if I do 2 times 83 minus 11, I would get a total of 155.
Okay. Now we talked about being able to kind of check ourselves just to make sure that we're on the right track. We could really check ourselves a couple of ways here, right? I could make sure that now that I've put those values of x in, that these two angles do in fact equal the 155. And if you check that, they will. But you can kind of check yourself a couple of ways too, just to make sure that you're getting those right angle measures. Okay. So they said x is 83. They also asked for the exterior angle, so probably listing the 155.
Say exterior angle is 155.
Yeah, probably good.
What's the? You said a couple different ways. What's the other way you could check? Could you find the other interior angle?
Sure. Oh yeah, I guess I didn't really state it.
Yeah.
Okay,
so you could find that. That would be 25.
And then once I know that,
And
what
then
should
if
be
I
true
add
about all of these?
those should all add up to 180.
Yeah.
So there's just a variety of ways to do
Variety
that.
of ways to check yourself.
So the next question, it says the measure of one acute angle of a right triangle is 1/4 of the measure of the other acute angle. Find the measure of each acute angle. So what's something that could maybe help us kind of manipulate this problem?
I'm thinking we need to draw a picture.
All right, so what would I draw?
We're talking about a right triangle, so let's draw that right triangle.
And we don't really know anything about the sides of this right triangle. And you'll notice it only talks about the angles. So that's all we're going to involve. So we already know it's a right triangle, which means one of the angles is a right angle.
Right.
Okay. What else do we know? It says the measure of one acute angle is 1/4 of the measure of the other acute angle.
Okay, so we're obviously talking about those angles that are not the right angle, because those are
this
acute.
angle and this angle here.
They don't really tell me anything about either one of them.
Yeah.
But they do tell me kind of one in terms of the other.
Okay.
So if I know that one acute angle, let's just call one of them x.
I think that's a great idea. Because we don't, like Ms. Hookery said, she doesn't really know either one. So this angle could be x.
And then it says the measure of one acute angle is 1/4 of the measure
So how
of
would
the
I
other
write
one.
that?
So I probably would want to write 1/4 x.
So 1/4 of that measure. So 1/4 x.
Yeah.
Good. Okay.
Okay, and then they tell me to find the measure of each angle. Okay, I am thinking that, well, I'm thinking of two different things. I'm thinking of the fact that we could use triangle sum theorem.
Yeah.
But we learned a corollary to the triangle sum theorem that I think is probably going to help us out on this, because I know that those two angles together just equal 90. They're complementary.
Yeah.
So I don't really have to use that plus 90 to equal 180. I can just go with the
So
x.
those acute angles are complementary. I'm going to write down what you kind of said there. Kind of important. So we know that those two angles add up to 90, you said. So we could go ahead and say what you're going to say.
I was just thinking, so we could write the equation x plus our 1/4 x would equal our 90.
Yeah. You don't have to worry about that right angle at all because there's no reason for it.
Right.
Always that will happen. Okay.
All right. Now, I'm thinking to solve this one, I might clear the fractions just
Okay.
because I don't love working with fractions if I don't have to.
Okay.
So if I multiplied everything there by 4,
So everything, you just kind of either show it that way or you can do what I often do. We'll just
put the
kind
big
of put the big
parentheses.
parentheses around it. So I get 4x plus an x.
plus an x equals 360. And then I can combine those to get a 5x. And that would leave us with 72.
Okay, now it said find the measure of each acute angle. Did I finish it?
Well, no, I've only found one, really.
Okay, so 72 degrees is one acute angle. What's the other one?
The other one is 1/4 of that, so that would be 18.
Now, is there a way we could check to see if we got some good answers here?
Well, sure, because I know that those two together should equal 90.
Yeah.
And they do, so that's a good
Together,
thing.
if I add those up, they should equal 90.
And if I forgot the corollary, I could even add it to the 90 to get 180, which they do that too.